We're going to start out on page 71, and we are in section 8.3. You covered hypothesis testing for proportion during your class, so we're just going to go over an example to review a hypothesis test with proportion. And so there's six steps when you're doing a hypothesis test, whether it's proportion or another parameter. You want to check the requirements, state the null and alternative, calculate the test statistic. So at this point, if you're using a calculator, you can let the calculator do that. You want to look up the p-value. That's the area under the curve that corresponds to your test statistic. And think about whether it's a right-tailed, left-tailed, or two-tailed test. You get that from the null hypothesis and the alternative. Then you compare the p-value to the alpha level. If the p-value is less than the alpha level, then you reject the null. Okay, so this is really important. If the p-value is less than alpha, you reject the null. P-value is greater than alpha, then we fail to reject, or we do not reject. And then lastly, we give a conclusion, and the conclusion should always be in context of the problem. All right, so let's go ahead and do an example. After reading the example in the book, try the following problem. In a study of 11,000 car crashes, it was found that 5,676 of them occurred within 5 miles of the home. Use a 0.01 significance level. So that means that alpha is equal to 0.01. And so that means if the p-value is less than 0.01, we reject H naught. Okay, so we want to check first to see if the conditions are met. One condition is that the sample size is the sample size times the proportion is greater than or equal to 5. And so we have an n of 11,000 times 0.5, I don't know what that is, but that's certainly greater than or equal to 5. Then Q, remember, is 1 minus 0.5, so that's 0.5 as well, so we're good there. If it's a simple random sample, we don't know, it's not told in the problem, but we do have independent trials with two outcomes. Either it was or was not within 5 miles of your home. Okay, so now we want to give the null and alternative. So the null hypothesis is H naught colon, and this P is always in the null hypothesis if it's proportion, and the equal sign's always there, and 0.5. A lot of people write the null like this, and that's wrong because you want the P in there. And the alternative is going to be P is either greater than, less than, or not equal to 0.5. And so we go back up to the problem, and it says more than 50%. So more than 50% means that we would have a proportion greater than 0.5. Okay, so that's how I'd state the null and alternative. The test statistic is the sample data, and we want to make that into a proportion. So we come back up here, it says of the 11,000 car crashes, 5,676 of them are within 5 miles of the home. I want to make that into a proportion. So my p hat then is going to be 5,676 divided by 11,000. And so that's going to be equal to 0.516. Now I can calculate my test statistic. I'm going to go ahead and just draw a picture here as well. So I can draw my normal curve. 0.5 is in the middle. My test statistic is out here, 0.516. Because my alternative has greater than in it, I want to find this area right here. Okay, so I calculate the test statistic. I take 0.516 minus 0.5. Remember, p hat's from the data. P is from the null hypothesis. And then I wanted to take the square root of 0.5 times 0.5 divided by your sample size, so 11,000. And so our test statistic is going to equal 3.36. And then I need to open up the normal table here. Sorry, forgot to open up the normal table. Here it is. Okay, so positive 3.36. I'm going to find that down here. Alright, so here's 3.3, and I go out to 3.36, so that's going to be 0.996. I'm going to go back to my problem. But I want the area to the right, and so I take that and I subtract that from 1. Okay, because remember we shaded in the area to the right, and so that p-value is going to be equal to 1 minus 0.9996. And that's equal to 0.0004. And that's the p-value. So that's what I'm asking for here. And so number 5 is the p-value reported above or less than the significance level of 0.1. Oh, sorry, is the p-value reported above, that's 0.0004, less than the significance level of 0.01. Well, certainly 0.004 is certainly less than 0.01, and so the answer here was yes, and we've already set up here, if our p-value is less than 0.01, we reject H naught. And so therefore we reject the null hypothesis. Okay, so let's go ahead and do that on the calculator as well. So here's my calculator. I want to go to Stat. Oops. Go back to Stat. And then I want to go to Tests. And now this is a one proportion z-test. And so that's going to be number 5, one prop z-test. Okay, then I hit Enter. And I want to put in all my information. So I want to put in, oops, that's not the right one. I want to go to one prop z-test, which is number 5. I went to number 6. Okay, so I want to put in all my information. This is the number that's in your null hypothesis. You can remember this by the 0 sign right there for null. So that's going to be 0.5. X is the count, and not the sample size, but the count that met whatever proportion you're looking for. We want 5, 6, 7, 6. And then we want our sample size, so 11,000. And then we want to give the direction of the alternative, so we have not equal to, we have less than, or we have greater than. And we had greater than in our alternative, so I want to click on here. Oops. And then I just go down to Calculate and hit Enter. Okay, so it gives us our test statistic, just like we got, 3.36. Gives us our p-value. This means -4, so I move the decimal over to the left 4 places, so we get a p-value 0.00039 or 0.0004 like we got. This was the sample proportion, 0.516. Okay, so that's how you do it on the calculator. The only thing left that we have to do is write a conclusion, which sometimes is the hardest part of the problem. Okay, so let's see what we have so far. We have that we reject the null. So I'm going to come up here. If we're rejecting the null, then we're going to accept the alternative. And so what does the alternative say? Well, it says that the proportion is greater than 0.5. Okay, so we're rejecting the null. We want to make a statement saying that we're accepting the alternative. So I come back to my problem, and I want to state in words what that means. We're testing to see if the proportion of car accidents within 5 miles of the home is greater than 0.5. Sometimes it helps to go back to the problem. It says we want to test the claim that more than 50% of car crashes occur within 5 miles of the home. So the answer is yes, we did that, or no, we didn't. In this case, since we rejected the null and accepting the alternative, we did show that more than 50% of the car crashes are within 5 miles of the home. Okay, so let's see. So because our p-value is less than 0.05, we reject the null hypothesis. Now notice I haven't put it in context of the problem yet. Therefore, we can conclude that more than 50% of car crashes are within 5 miles of home. Okay, so I said we rejected the null. That was based on our p-value being small. And then I also said we concluded that more than 50% of the car crashes are within 5 miles of the home. And I said that because we rejected the null and accepted the alternative. And the alternative says that the proportion is greater than 0.5.